Hey everyone, in this video, I'll discuss a couple of applications of normal distributions. Let's say if the mileages per gallon of a car Model S is normally distributed, and they found that the mean of the population is about 32, and the standard deviation is about 2.3. Again, this is a random variable, and the variable x, in this case, it's going to be the PMG of all the cars of this model. So in normal distributions, and if you want to use spreadsheets, Google spreadsheets or Excels in order to calculate the probabilities of the values, you can use these two functions. The first function is a norm distributions, which you can give you the probabilities of a given value. And the second function is norm inverse, which will give you the values given a certain probability. All right, let's use the normal distributions properties to answer the following questions here. The first question is, can you find the probabilities of picking a random car, in these populations in all the cars of this model? And then you find that the MPG of that car is less than 28. So you can convert this problem into a mathematical problem, right? Finding the probabilities of the random variable x that is less than 28. And we can use the norm distributions functions here to figure out these probabilities. So first you want to add the value of interest, which is 28. And since this is like the less than the probabilities that on the left of 28, then this normal distribution function will give you the probabilities on the left of a certain value. All right, and then you want to enter the mean, standard deviations, and the cumulative, which is like the cumulative area is true. Okay, so that will give you about 4.1% of the time that you can pick a random car whose MPG is less than 28. This is the area on the left problem. The next problem is find the probability of picking a random car, and then you figure out that the MPG of that random car is greater than 34. So this is a problem, finding the area on the right. In order to find the area on the right, P of x greater than 34, we know that the values here is the same as 1 minus the probability to the left of 34, right? So I can just 1 minus normal distributions, and I pick 34, use a mean, and standard deviation, and true. That will give you an answer of about 19.23% of the time in which you pick a car whose MPG that is greater than 34, a car of this model. About 4% up here, about 20% down here. All right. Then the next question is find the probability of picking a random car whose MPG is between 28 and 34. And we know that this is a problem finding the middle probabilities problems, right? So in this kind of problems, you can use find the probabilities to the left of the bigger value and subtract the probabilities to the left of the smaller value. This is the bigger value, subtract normal distributions of the smaller value, which is 28, not 18. 28, 32, deviations, and cumulative is true. What's this? All right, so the answer is about 76.67% of the time in which you pick a random car that is, that has an MPG that is in between 28 to 34 miles per gallon. All right. So these three examples here are shown how to use probabilities of properties of normal distributions in order to answer questions about a random car, picking a random car from the population. The next questions will address the probabilities of the mean of the sample, right, of a population. So the questions can be picking a random sample of 20 cars from, all the cars of this model. And you find the probabilities that the mean of the sample will be greater than 34. Okay, so the mean of the sample, you're picking a sample of a size of 20, and you find, the mile per gallons of each of the car, and you take the average of the 20 cars, right? And then you want to figure, okay, so now I have the average, the mean of the sample. Can I figure out the probabilities of the mean of the sample is greater than 34? The answer is yes. Do you know that using the law of large numbers, we figured out that the mean of the samples is about the mean of the populations. And the standard deviations of the mean of the samples is about 1 divided by the square root of the standard deviation of the population. So then we can have a table of the size of 20. And the mean is about 32, it's the same as the mean of the sample. And the standard deviations is about 0.51, because I take the standard deviations of the population divided by the square root of the sample size. So I took 2.3 divided by square root of 20. So in this case, as we know that because the population is normally distributed, then the distributions of the samples means is also normally distributed. So then we can use the properties of normal distributions in order to answer this question. Okay. Size of samples of 20 cars, find the mean of the miles per gallon of those 20 cars, and figure out what is the probabilities of the means of the sample will be greater than 34. And I use X bar as the mean of the sample, right, instead of X. All right, so the same, we just need to use the normal distributions, the interest values to 34, the mean is 32, and the standard deviation now has to be this value, right, the new standard deviation for population mean. Oh, and cumulative is true. Then this is the probabilities of picking a car that picking a sample of 20 cars whose mean of the MPG is greater than 34. The answer is about 99.99%. So if you pick a random 20 cars, you find the means almost 100%, right? 99.99% of the time. The mean of the, oh, no, it's about 1 minus. Sorry. So this is the on the right, area to the right. So we have to take 1 minus the area to the left. So that means, that's why it doesn't make sense when you say 99%. The sample means would be greater than 34. That doesn't make sense. Okay, so the answer is the opposite, almost none, almost 0% for when you pick a sample of 20 cars and the sample means of that sample will be greater than 34. Compared to if you pick a random car, then 20% of the time you can have a car that is, that has a, MPG is greater than 34. But if you pick a samples of 20 cars, then the probability is much lower, and it goes to very close to 0. Okay. The reason is when you pick samples of a certain size, the standard deviations decreased a lot because you divided by the square root of the sample size. And since the standard deviation decreases a lot, then you don't have a lot of room on the right, right? And you go from the mean to 0.5 is 1 standard deviation. As you go to 3 standard deviation, is like the mean plus 1.5. It's an 0.5. So then, and then 34 is 2 miles, away from the mean. So it's more than, so the 32 is about 4 standard deviation away from the means. That explains why the probabilities is so small for samples of 20 cars to have their average MPG to be greater than 34. All right, so you just want to pay attention to whether you're finding the probabilities of a random car or the probabilities of the mean of a sample of 20 cars or 30 cars or 40 cars. So the means of the same populations and the sample means are the same, but the standard deviations of the sample means is much smaller. And as you see that as the size of the sample increases, the standard deviations decreases. So then your normal distribution curve is getting narrower, narrower, narrower. All right, so these problems are about finding the probabilities of either picking a random car or picking a random samples of 20 cars. What about if you're given a certain percentage, of your populations, can you figure out the value that corresponds to those percentages? Here's a first example. Find the lowest MPG of the top 10% MPG. You can see the pictures, you have the top 10% here, and you want to find this value here, which is the lowest MPG, right? The top 10 MPG. This is the area to the right problems. I know that the area to the right is 0.1, so that I can find the area to the left, which is 1 minus the area to the right. And I can just use the norm inverse functions. And I plug the value, the probabilities to the left, 0.9. I plug the mean and the standard deviation to find the X value. So this tells you that the lowest value, the lowest MPG of the top 10% of this populations is about 34.94 miles per gallon. That means if you look at all the cars of this model, right? And then you test all the cars and you find each of the cars miles per gallon MPG. And then you have like top 10%, so which means cars are perform the best in terms of gas, fuel efficiencies. Then you have like the area to the right of the tail here. And then you found, okay, if a car is on the top 10s of like gas, fuel, then the lowest miles per gallon should be about 35 miles per gallon. Okay. How about the second question is, okay, so now if you look at the bottom, performance, right, the lowest 30% MPG, then what is the highest bar that is separated from the 30% to like the better 70% on the right? And in this case, that you're looking at the probably on the left to be 30%. So then I just going to use normal distributions of normal inverse, sorry. So you have to use normal inverse and put the probabilities to the left, the mean, and I shouldn't use a mean here. I should use a mean in the population, right? Because picking a random car and the standard deviations So then you will have this, the value is about 30.89, 30.8 miles per gallon. What does that mean? That means if you look at the lowest, 30% of the performance in terms of gas efficiency, then the highest value of the lowest 30% is about 30.79 miles per gallon. You look at here, 30% on the left, and this is the point, the highest value of the lowest 30% performance. All right, so these two questions here are about finding the values in the populations given some probability that corresponds to those values. I hope that you guys will be able to apply probabilities of normal distributions into real world applications. Also know how to use Google spreadsheets to find these problems, to find out the answer for any of these questions.